ladies and gentlemen, to this video lecture. Let us take a look at this example. So we are given this function that sends x to the cube root of x. And now the question is, determine the second Taylor polynomial p2 about 8 of f, and use p2 to determine an approximation for the cube root of 7. Okay, so let us, before we start, discuss this question. So what is the cube root of 8? We know what the cube root of 8 is. That is 2. And we can easily determine the derivatives of f. That is easy. And we can work out the derivatives of f at 8. The first derivative, second derivative, etc. We cannot do the same with 7. 7 is a prime number. We're trying to take the cube root of a prime number. That is an irrational number. So we do not know what the cube root of 7 is. We do not know what the derivatives of f at 7 is, without knowing what the cube root is, etc., etc. So we do not know, or it is very difficult, or without any other information, it is difficult to work out the cube root of 7. So what we will do is we will use the Taylor polynomial to work out an approximation for the cube root of 7. And we will use the Taylor polynomials about 8, because we can easily compute the cube root of 8 and the derivatives of this function f at 8. And we will then use that to compute an approximation for the cube root of 7. Okay, let us do that. So f of x is, let's write it this way, x to the 1/3. The derivative of f of x is, that is going to be x minus 2/3, 1/3, and the second derivative of f is going to be, that is minus 2 over 9, x minus 5 over 3. So here we've got the first and second derivatives of f. So now we are interested in the Taylor polynomial about 8. So we want to know what the values of the function and its derivatives are at 8. And all that we do is we just plug them in there. So of course the cube root of 8 is 2. You plug in 8 here. This is 1/3. Let's write it this way, x squared 1 over x to the 3rd, so that is 2. So that is 1 over that is 1 over 12. That is cube root of 8, which is 2. So that is 1 over 3 times 1 over 4, which is 12. And we can easily work out what the second derivative of f of 8 is as well. That is not too difficult, and if you do that, you can see that it is minus 1 over 44. So we can write out the Taylor polynomial of f about 8. So the second Taylor polynomial, so the second Taylor polynomial of f about 8. About 8. And that is just, you just read off the definition. So f P2 of x, that is f of 8 plus derivative of f at 8, x minus 8, plus second derivative of f at 8, x minus 8 squared over 2 factorial. And if you work that out, that is equal to 2 plus 1 over 12 x minus 8 minus, and now it is 1 over 2, 1 over 144 x minus 8 squared. Okay, so here we've got the second Taylor polynomial of f about 8, and we can approximate the cube root of 7 now by computing the value now of the second Taylor polynomial at 7. So you just plug in 7 everywhere. So this is, what is it going to be? 2 plus 1 over 1 over 12, 7 minus 8 minus 1 over 2, 1 over 44, 7 minus 8 squared. So that is 2 minus, oops, did I make a mistake? But not 17, 12. That is minus 1 over 12, and this is minus 1 over 2 times 1 over 44. And if we work that out, that is 551 over 288, which is roughly, is exactly, has a decimal expansion 1.913194 repeating. So 4, 4, 4, 4, 4, 4, 4, etc. Okay, and maybe let's go to Wolfram alpha. Let us work out what is the cube root of 7 and get a better approximation and compare it with what we got. Taking a while. Let's try again. Maybe it doesn't understand cube root of 7. Let's it's coming. Appears to be particularly slow. Is that 7, 3? There we go. Cube root of 7, 1.912931. And what did we get? 1.91319, 1.9129. So here the third digit is, well, we make an error there. But 1.91 is a fairly good approximation to this to the cube root of 7. Okay. And maybe let us also take a look at what we've got here. So here I have plotted the function f. So this f is just sends x to the cube root. So here is the graph of f. And if we look at the second degree Taylor polynomial about 8, that is a parabola. If we zoom out, we should be able to see that it is a parabola. So that is a parabola. And specifically, since it is the Taylor polynomial about 8, it matches both the function value of f and its derivative here at 8. And if we just compare the graphs of the function f and the second Taylor polynomial, this orange curve here, we see here at 7, it is a fairly close approximation to the actual value of the cube root of 7. Okay, and that is it for this example. I will see you in the next one.